Okay, this is 1.4, finding limits from tables. You will need your graphing calculator, so I do have an app that kind of mirrors the TI-84, but it's going to be a little bit different. Some of the functions will be the same the way you do things, but it's just going to look a bit different, so you may have to figure out how to modify it for your own use. Again, if you're struggling with your calculator, please come and talk to me, but you definitely need to use a calculator for this section. Okay? All right, so let's take a look at finding limits from tables. If we have the graph, it is easy to see the value of limit as x approaches 3 of f of x. So if we look at this graph, this is f of x here. If x is approaching 3, then the y value is approaching the number 4. Okay? Without the graph, we could also use a table of values. Now, as long as we know that the function is continuous, meaning, I shouldn't say that actually. As long as we know the values leading up to a certain point for x, we should be able to find the values for y. Okay, so look at the table of values below. And as we approach 3, you can kind of see that we're getting closer and closer to x equals 3, right? So here and here from both directions. Remember, for a limit to exist, it has to exist on both sides. Okay. So as you approach 3, what is this value approaching? The y value is approaching 4. Okay? That makes sense. Okay? Next one. According to the table, what's the value as we approach negative 4 of f of x? If I look at the table, negative 4.4, negative 4.001, we're approaching a specific value here from both directions. So what is the y value approaching? Hopefully you see that it's approaching 2.5. Right? Now, what if you're not given a table and you have to find your own? So here's a function. Create your own table of values to help you evaluate the limit as x approaches negative 2 of f of x. So this is where the graphing calculator comes in. So on the right side, if you push this top left button where it says y equals, and I already went ahead and put in the equation, go ahead and type it in. The variable button is this one down here, right next to alpha. The xt, I think the 84s might have some different symbols there, but that's your variable button for x. You need the exponent button, which is the caret, the arrow that points up right here, right below the clear button. So x cubed minus 4x squared minus 7x plus 10. You do need to put that in parentheses. If you do not, it's not going to do the math correctly. We divide, you can use the fraction button, x plus 2. Okay? And you can graph it. Okay? So my graph is going to look different because it's an app, but you can graph this. Now, if we want the table of values, you can hit second. Okay? So we have this equation. You hit second in the top left. And on the right side here, above the word graph, it says table. So if I use second and then graph, it gives me the table of values here. Okay? So what numbers can we put in? We're trying to approach negative 2, so maybe something like negative 2.1, negative 2.001, negative 1.999, negative 1.9. Now, I actually need to, let me redo this real quick. Sorry, that didn't look right. If you do second table, where is the second table? Oh, no. Why isn't it working? Second table. What is going on here? There you go. Okay. It's giving you specific values for x that is not very useful for us. Okay. Right. So negative 3 isn't close enough. Negative 1 is not close enough. Now, I believe you can type in numbers like x is negative 2.1. No, maybe not. Sorry. Some calculators did that, but I guess not. Let's see here. Second table set. Now, if you want to change the spacing here, notice the x values are spaced out by 1s. If you want to change that, if you go to second window, which is next to y equals, The delta table, that's how we change it. So if I want to change this to a smaller value, let's see here. If I want to change this to a smaller value, maybe 0.1, okay? Let's see here. See, now we are spaced out by 0.1. Now we're trying to find the limit as we approach -2. Let's see here. Won't do that for me. So I go to -2, right? It's indeterminate, which makes sense because if x is -2, denominator is 0. But I do have a value for -2.1, which is 22.1, right? 22.01, sorry. And I do have a value for -1.9, so 20.01. But that's not enough to see the y value that we're approaching, okay? So how do we fix that? How do we get a better possible answer? Now, if we want to use this table function, you can change this. Down here it says independent and depend. Instead of auto, change it to ask. And then let's go back to the table. So now we can type in specific values. So -2.001, actually. And notice it gives me a value. Now, my calculators give me like 5 decimal places, 6 decimal places. I think your TI-83s may only give you 2 decimal places, so just be mindful of that. Okay. So this is 20.99001, and this is 2. So what are we approaching? It looks like we're approaching the number 21. So this is by using a table, but your calculator may be limiting the number of decimal places. So how do we fix that? Okay, so let's go ahead, go to quit. Second mode takes you out of the window. You can quit. Now, as long as you put the equation in y equals, I think it might, for you guys, it might be under y1, but for me it's under y0. Okay? We can evaluate for specific values. So if I hit vars, and I believe you have y vars somewhere, so scroll to the right, make sure you get to y vars. And if you put the equation in y1, push y1, I'm going to push y0 because that's where my equation is. Use a parentheses, and if I type in -2.001, it gives me the y value associated with it. Now, this is how you can get a more accurate decimal placement values compared to your second table. Okay? I can do that again. I could redo everything. I can re-input the y0 by doing this. So this is kind of a tip that you guys might want to memorize. If you do second, entry, so enter, bottom right, it types in what you just put into the calculator. So instead of y0 of -2.001, I'm going to put -1.999. Okay? And I'm going to get even closer. So I'm going to do second entry again. I'm going to throw in another 9. Notice how I'm getting closer to a specific number. I'm going to throw in one more 9. Oh, now we're getting too close. It says indeterminate because the denominator is becoming 0. Okay. Now on the AP exam, if you have to write out a decimal value, please write it out to 3 decimal places. Okay, they'll mark you down if you do 2. So make sure you go to 3 decimal places. You can round to 3 decimal places, or you can truncate to 3 decimal places. So this table here, these, actually let me highlight this. This one, these 3 are not very good for us because we did not round to 3 decimal places. Okay, at least 3 decimal places. This one is okay because we got more than 3. Okay? All right. Function f is continuous and increasing for x greater than or equal to 1. The table gives values of f at selected values of x. Approximate the value of x of the limit as x approaches 2 cosine of f of x. Now, they do tell us it's continuous and increasing. Now, this is important for x greater than 1 because they don't tell us that. Right, here's 1. It's increasing, or it could be doing this, or it could do this. If it's not continuous, we could have a hole, but we know it's increasing and continuous, so it's always going to go up. Okay? The table gives values of f for selected values of x. Approximate this value. So as x approaches 2 of f of x, what are we approaching? We're approaching the number 5. So this becomes a limit cosine of 5. Okay? Now we can evaluate this because this is just, a function that's being evaluated, cosine of 5. If I wanted to do cosine of 5, please make sure your calculator is in radian mode. So if you hit mode, now this is going to look different, but there should be degree, radian, gradient option. Make sure it's under radian. Okay, so cosine of 5. So the limit as x approaches 2 of cosine of 5 is going to be 0.284 if I round it. Okay, if you truncate it, this is rounded, it's 0.283 if you truncate. Now, if you don't remember what truncate means, it means we just cut it off. Okay, we just cut off the end. Okay. Hopefully this makes sense. If you have questions on your calculator, please make sure you come see me. If you have any questions, come to FlexTime, ask questions in class. Okay.